Professor Gilbert Hegemier is one of the founding faculty members in the Department of Structural Engineering.
He had a training in aerospace engineering, and he came here and had this vision to understand structures and then actually making a lab that can take a full-size structure and test it.
He really became, one of the first people that could think really big in terms of laboratories, like these just really incredible facilities that he either created or helped create.
Well, I'll tell you how it all happened. I was aerospace. I was working on rockets that were going to go to the moon and so on and so on. So I was very familiar with the bridges that collapsed in the 1971 San Fernando earthquake. And so I went to NSF and I said, look, how about if we take a look from a different perspective, the aerospace viewpoint? And the problem was we didn't have facilities for testing on campus.
There's something called scaling, right? You can't build like a little half-size model or a quarter-scale model. It's not gonna scale properly and behave properly. And so really the only way to comprehensively know is to build it at real life scale.
And I finally went to the chancellor. I was lucky. That was Richard Atkinson, and he saw the problem, he saw the vision, and he worked with me to build the facilities that you now see. He was really important in that respect,
To understand big things, you have to test big things, and I think he got that and knew it. And so, with maybe a few other of his colleagues at the time, really were able to develop new ways of testing that, we're all still using some of these techniques now and have built off of it.
But he was definitely involved in pioneering the joining of civil structures, concrete materials to aerospace materials, and encase concrete structures with them to dramatically improve their seismic performance against earthquakes and things like that, and reinforce them or repair them. And then later on apply that to the explosive blast. And that was, I think, very groundbreaking.
I got into the blast business after watching in '83 in Beirut, Lebanon, what happened to the Marine barracks. I could not believe it. A truck bomb took down that structure, and the collapse of the structure is what killed most of those folks. One column that failed in that building caused that catastrophic collapse. So the things we try to do, whether it's earthquakes or blast, is to prevent the collapse first of the structure, because that can lead to a lot more deaths than the actual blast load in many cases.
In the past, when people were trying to study the effects of blasts on structures, they would put an explosive device next to the structure. But when this explodes, you have a lot of dust and gases, so you're not able to visualize what's happening.
And so this was just an impossible task out in the field. So I decided, look, let's go build a blast simulator.
That can basically use impact impulse momentum to simulate very fast rise pressure pulses on structures.
Because there was no dust or gas, you could see the full process of the explosion. So in addition to understanding how blasts affect structures, he was able to come up with ideas on, if the blast happened, how could the structure still survive?
And I understand that he's consulted with and has applied a lot of his knowledge to a lot of US embassies and things like that.
It's one thing to do a design analysis. Computer simulations are great. Now, once you do a full-scale or a large-scale test, it's hard to argue against the result.
That's what Gil has been able to do so exceptionally, from aerospace to structural engineering, from earthquakes to blast. He's really found a way to tie in applications that really change the way that we design structures.
I think Gil's legacy that is living on within the department are the world-class research facilities that we have. In addition to the hard infrastructure, he also recruited some of the people that are working in the laboratories.
And just seeing the people he's been involved with and what they're doing, what we're doing, definitely I think he he's built a future of resiliency among people as well as is among structures, for sure.
It's rare in life that you meet people that you feel connected to, as well as you just want to hear about what they're doing. And I think a lot of us, we just learned so much from him. And so, my career wouldn't be anywhere close to where it is without him.
What I've done at the university is to add a new dimension, and that dimension has been structural engineering viewed in a little different light than is traditional. But again, I think that's been a new dimension, and I think it's been good for the university. Well, what else can I say, right?